Just a couple more examples here in case you need some. So we're going to use the multiplication rule to find out the probability that if I spin both of these spinners, what's the probability that I get two reds? Are they independent? Yes, two spinners. Does the order matter? In this case, it's both red, so no, it doesn't matter because they're both the same thing. So the probability that I get a red on this spinner is 1/4, and the probability that I get a red on this spinner is 1/5. Nice and easy. 1 out of 20 that they're both red. I could have said, what if I spin this spinner first? 1/5. What if I spin this spinner second? That's the same thing. It's still going to be 1/20th. So if you want to picture this as a probability tree real quick, this one has 4 options. Each one of these would have 5 coming off of it. 5 coming off it. So I would have 4 with 5 each. That's 4 times 5. That's 20 options. And one of those is going to be red and red. 1 out of 20. So that's a quick visual of what we're doing here just mathematically from what we were doing with probability trees and such. In this case, a four-sided die. Four-sided dies look kind of weird. I know there's 3 numbers over here, but whichever one's facing straight up is the number it lands on. So four-sided die, what's the probability with order that I roll a 1, a 2, and then a 3? So 3 rolls, a 1, a 2, and then a 3. Well, if it's four-sided die, then it's a 1/4 probability that I roll a 1. What's the probability I roll a 2? 1/4. What's the probability I roll a 3? 1/4. When I multiply those together, I get 1. 4 times 4 is 16 times 4 is 64. 1/64. Again, as we mentioned, it gets a little bit trickier when there's no order. No order. Because here, do I care if I get a 1, a 2, or a 3 on the next one? I don't. So the probability of getting a 1 or 2 or a 3 is 3/4 on the first. The probability then, I need to multiply by the probability that I get the other 2, one of the other 2, which would be 2 out of 4, because there's 2 remaining that I haven't gotten. I don't care if it's a 1 or 2 or a 3 on this one, but I do care that it's not the one I landed on the first time. So, and again, I need to multiply by the last one. Whichever one I haven't gotten yet, the probability of it getting the last one, which is the last 1 out of 4. So the probability here would be 3 times 2 is 6 times 1 is still 6. 4 times 4 times 4 is still 64. Right? These should be the same numbers because I'm rolling 3 times. There should be 64 options. In this case, there are more options because I don't care about the order. There's 6 ways out of 64 to get a 1 or a 2, a 1, 2, and a 3 in any order. In this case, there's only one way to do this: 1, a 2, and then a 3. There's only one way to do that. Okay.